Hi, welcome to Zona Mechanica. There is an MCQ on truss. The figure at the margin indicating the weightage of the question. There is a truss PQRST as shown in the figure. The distances are given. All dimensions are in meters. And the two external forces F1 and F2 are acting at P F1, which is equal to 9 kilonewton, and F2 acting at Q upward, which is equal to 3 kilonewton. Well, the question is, what is the force acting in the member QS? Okay, so let us solve step by step by taking joints. Okay, so at joint P, so this is the joint P, and the force F1 is acting downward, is equal to 9 kilonewton. Let this is F3 and this is F4, and this angle is theta 1. Okay, so this distance from the figure is 2 and this distance is 1.5. Yeah, 1.5 is given. This distance is 1.5. That is, this is 1.5 and this is 2. So I'm writing here 1, 2, and here 1.5. 1.5. Okay. Okay, now. So clearly the F1 is vertically downward and F3 is horizontal. So considering the vertical components of the forces acting at P. Okay, so F4, if we resolve the force F4 in vertical and horizontal components, then F1 will be equal to F4 sine theta 1, right? Because F3 has no component in the vertical direction, it is a horizontal force. So F4 sine theta 1, this is a component of F4, vertical component, and F1 is vertical. So these two will be equal. So F4 sine theta 1. Sine theta 1 means this is theta 1, this is 2, and this is 1.5. So it will be 2 by root over of 2 square plus 1.5 square, right? So that is equal to F4 into 2 by, this will be 2.5. Okay, so again F1 is equal to 9 kilonewton, that is 9 is equal to this, so which implies F4 is equal to 9 into 2.5 by 2. Okay, so this is almost equal to 11.25, and this will be in kilonewton. Okay, because F1 is in kilonewton. Now at joint S, so from S joint you can draw like this. Okay, so this is nothing but the PS, that is F4. Okay, so F4, and this is F5, suppose, and this is F6. Okay, this is the joint S, and this is symmetrical about the vertical axis. Okay, so if this is theta 2, then this will be also theta 2. Okay, so considering the vertical components of all the forces acting at S, so we will have F4. So F6 has no vertical component. Okay, it's a horizontal force. So F4 cos theta 2 is equal to F5 cos theta 2. That means F4 is equal to F5. Okay, therefore F5 is equal to F4, which is equal to 11.25 kilonewton, right? So F5 is nothing but this QS, the force acting in QS. Now the direction, what will be the direction of nature of the force F5? See, at joint Q, F2 is acting upward. That means F2 will try to pull the joint Q upward. Okay, and at S, as at the joint S, due to force F1, the force acting in the member PS will try to push the joint S downward, because F1 is downward. So two opposite direction, the two forces acting at these two joints are in opposite direction. So the force acting in member QS will be in tension. Okay, so this will be tension in nature. Okay, so clearly it's matching with option A, 11.25 tension. So the option A is the correct answer.